Okay, so some of the main concepts we've looked at so far this unit include finding lengths of line segments using the distance formula, calculating slopes of lines to compare how lines compare with each other, especially if they're perpendicular, and looking at right bisectors or anything along those lines. And we looked at equations of circles and midpoints. So some of the things we use all those for is to classify classify types of shapes when you look at them in a coordinate grid. So just to get us started here, if you're looking at classifying triangles, we did an example like this when we looked at distance formula, but some of the things we can find out when we're looking at triangles are whether they are scalene, isosceles, or equilateral. So you can find that out looking at the lengths of each side. And we can find out if there's a right angle there or not looking at either the slopes of each side to see if any slopes are negative reciprocals of each other, or if the side lengths satisfy the Pythagorean theorem. So we did one like that a couple of lessons ago. And now we can extend that and looking at types of quadrilaterals as well. So some of the special quadrilaterals you've seen are parallelograms. So if you have a parallelogram, what makes that what makes the shape of a parallelogram? Well, it's a quadrilateral, so there's four sides, and the opposite sides are parallel. So if we're trying to prove that something's a parallelogram, we just need to show that all the opposite sides are parallel to each other. Well, how can we show they're parallel? They would involve using the same slopes. So if they have the same slopes, they are parallel. Okay, so special types of parallelograms include a rectangle. So a rectangle is just a special parallelogram but happens to have 90-degree angles in it. So if you show it's parallel, we know it's a parallelogram. We can take it a step further and show that adjacent sides are perpendicular by seeing that slopes are negative reciprocals of each other. And if that's the case, well, then we know we have a rectangle. Taking a little bit of a step further, we can look at a rhombus. A rhombus is just a special type of parallelogram with all sides being equal to each other. So if we show the opposite sides are parallel, again, we know we have a parallelogram. And if we see that adjacent sides are equal in length, we know we have a rhombus. Okay, so it's again another special type of parallelogram. And then we have a square, and a square is really just a parallelogram with all equal sides and 90-degree angles in it. So we show everything we need to for a rhombus, but then we also have to show that adjacent sides are perpendicular as well. So again, a lot of things that we can show, and again, all this is done using distance formula and slope, so nothing new here. We're just putting everything together to try and again see what kind of shape we have. So let's do an example and see how it looks like. So here's a quadrilateral ABCD, and I'm giving you the four coordinates of each point. And I just want you to tell me what type of quadrilateral it is. So I'm going to walk through this because it's our first one. I'm going to walk through it with you. And what I'm going to suggest we do to start is just make a quick little sketch. Okay, so if you have grid paper in front of you, use grid paper. I don't need to make a super accurate sketch. I just want to see everything sort of laid out so I can see where everything is. Okay, so point A is at 1, 5. B is at 5, 1. C is at 2, negative 2. And D is at negative 2, 2. Okay, so what I have is quadrilateral A, B, C, D. Now, your sketch is probably going to look a lot better than mine. Again, I don't need an accurate sketch necessarily, because even if I have an idea of what the sketch looks like, what the quadrilateral is just by looking at the sketch, I still need to be able to prove it using slopes and distance formulas. So an accurate sketch can give you a guess of what the type of quadrilateral you're going to have, but you still need to be able to show me the math to prove it. I won't just justify. I can't give you full marks on a test or a quiz or an exam if you look at a shape and say, oh, it's clearly a square or a rectangle, without showing any math to prove it. Okay, so again, the sketch will give you an idea, but we still need to be able to show all the math. So what I'm going to do first here is I'm going to calculate the slopes of each side. Okay, so that means I need to calculate the slope 4 times. I'm going to find the slope of AB, the slope of BC, the slope of CD, and then the slope of AD as well. Okay, so again, calculating slope is something we did back in grade 9. I'm going to write out the coordinates here just for reference here. This is 1, 5, 5, 1, 2, negative 2, and of course negative 2, 2. So I'm going to have you calculate the slopes of all these sides. I'll do the first one with you. So if I'm going to go to do the slope between A and B, remember slope is rise over run. So y2 minus y1 will be 1 minus 5. So taking the y values of the 2 points, subtracting them. In the same order, I subtract the x values. So 1 minus 5 over 5 minus 1. So that gives me a slope of negative 4 over 4, which reduces to negative 1. Okay, that's a slope of one side. I want you to calculate the slopes of all the other sides. So do that on your own and push play and ready to go through the answers together. Okay, so if you look at all my slopes here, I have two of my slopes, AB and CD. So these two sides right here have slopes of negative 1. The other two sides have slopes of positive 1. So let's just think about what this means first. We're trying to put all of this information together. So right now the side AB and CD have the same slope, so they're parallel to each other. And ditto with the sides AD and BC. They're the same slope, so they're parallel to each other. So right off the bat, I know just by looking at this that I have a parallelogram, some kind of parallelogram. If I take it even further, I can look at the fact that adjacent sides, so i.e. AB and BC, their slopes are negative reciprocals of each other, right? So remember this, if you think of a negative reciprocal, this would be negative 1 over 1 if you want to think of it as a fraction, and this would be positive 1 over 1. So again, if you flip the fraction, take the reciprocal, change the sign, these slopes would be equal. So these slopes are negative reciprocals of each other, which is telling me that these sides are actually perpendicular to each other, and that's true for every pair of adjacent sides. So at the very least now this is telling me, hey, I also have a rectangle at least. So I have a rectangle, and now the only thing I need to figure out is if this is going to be a square as well. How do I determine if it's a square? Well, I find the length of some of the sides. So if it's going to be a square, I need to see that two of the sides are going to be the same. Now, not the sides across from each other. We know those are going to be the same because it's a parallelogram. But if you want to try and find the lengths of two sides next to each other, for example, AB and BC, finding those lengths will tell us if we have a square or if it's just a rectangle. So let's take a look at that. What I'm going to do is I'm going to find, using the distance formula, the length of AB. I'm going to find the length of BC. So I'll go through the first one with you. Remember your distance formula. It's the square root of bracket x2 minus x1 all squared plus y2 minus y1 all squared. So using my distance formula here, I'm going to have x2 minus x1, 5 minus 1, all squared. And then y2 minus y1 will be 1 minus 5. So that gives me 4 squared plus negative 4 squared, which gives me a square root of 16 plus 16, which is a square root of 32. Okay, I'm going to do the same thing with BC. So going from B to C, x2 minus x1, 2 minus 5, all squared. And then negative 2 minus 1. So 2 minus 5 is negative 3. Negative 2 minus 1 is also negative 3. So square each of these, you get 9 each time. 9 plus 9 is 18. So what I can see here is that these two lengths are not the same. One is the square root of 32 units, one is root 18 units. So this is not actually a square, it's just going to be a rectangle. And again, you might have had that idea just by looking at the graph, but now we can actually prove it using geometry. So if you want to take it a step further, you can find the lengths of CD and the lengths of AD. What you should find is that the length of CD will also be root 32. The length of AD will also be root 18. Okay, so it's not necessary here because I already knew I had a rectangle from the fact that all my slopes were either so opposite sides are parallel to each other, adjacent sides are perpendicular to each other. So that told me I had a rectangle, and by showing that the sides are not all equal to each other, I now know I have a square. Sorry, not a square, a rectangle instead of a square. Okay, so that's how these work. What I'd like you to do is I'd like you to do example 2 on your own. So this one is telling you it's a triangle, and I'm giving you the coordinates. I want you to tell me if it's scalene, isosceles, or equilateral, and also tell me if there's a right angle in it. So I'll have you try that on your own. If you're completely stuck, you can refer to the example from lesson 12 when we did distance formula to sort of see how it works. But try it on your own and push play and ready to go through it together. Okay, so to classify the triangle, you have to first determine if it's scalene, equilateral, or isosceles. So to do that, you calculate the length of all three sides. So I showed the calculation of the distance formula once here to find the length of side AB, and got the square root of 125 units. I did the same thing for BC and AC. I didn't show the calculations, but you should get root 45 and root 80 for the other two sides. When you look at your results here, all three sides have different length. So because they're all different length, you can say it's a scalene triangle. And to check if it's right angled, we went through two different ways of doing it during the lesson. During lesson 12, sorry. One way was to check to see if the Pythagorean theorem worked. So if that's the case, a squared plus b squared equals c squared. Which one do I choose to test for my a, b, and c? Well, the longest side would have to be the hypotenuse, the c, so that's the root 125. So the right side of my equation, I'm doing a check here. If I take root 125 and square it, I get 125. If I do a squared plus b squared, it's root 80 squared plus root 45 all squared, which gives me 125. So because the Pythagorean theorem works, it tells me there's a right angle in the triangle as well. Okay, alternatively, what you could have done is found the slope of each side, the slope of AB, slope of BC, and slope of AC. And what you would have seen is that the slope of AC and the slope of BC were negative reciprocals of each other. And what that would tell you is that there's a right angle over there. Okay, so however you did it is fine, but in the end you should determine if it's scalene or right angle, that is scalene and right angled. Okay, one last example to try. So here it wants you to show that the mid segments of PQRS form a parallelogram, with PQ and RS being those coordinates right there. And it just has a note here when you are given the name of a quadrilateral that tells you the order in which the points are connected. So that means P is connected to Q, connected to R, connected to S, and then back to P again. So to just get a picture of what's going on here, it's telling you have a quadrilateral PQRS. This is going to be a very, very rough sketch, probably not accurate at all. But let's say I have a quadrilateral that goes something like this. 1, 2, 3, 4 sides. Okay, let's just say that's PQRS. It wants you to show that the mid segments of this form a parallelogram. Now, hopefully from doing your homework earlier on in this unit, you know what a mid segment is. And a mid segment is just line segment connecting midpoints. And they have to be adjacent midpoints. Okay, so what that means here, if, say, for example, you have a midpoint here of PQ, a midpoint of QR, midpoint of RS, this is obviously just a rough draw here, and midpoint of PS, then these mid-segments right here, if you were to draw them, you're trying to show that this forms a parallelogram. Now, it sort of looks a little bit like a parallelogram in my picture, but again, I have to prove it. So I need to show that this shape right here, this black shape, is a parallelogram. So for starters, I need to figure out is the coordinates of the endpoints of that shape. So I need to find the midpoints of PQ, QR, RS, and SP. Okay, once I have those midpoints, I'll have these points right here, and then I can try and show that's a parallelogram. Okay, so try and do this on your own first, and see what you guys can answer, and push play when you're ready to go through it together. Okay, just to show you an intermediate step here, I calculate the midpoints of all these sides, so I call them A, B, C, D. So A is the midpoint of PQ. I take my two x coordinates and average them out, 0 plus 2 over 2. I take my two y coordinates and average them out, 4 plus negative 2 over 2 gives me a midpoint of 1, 1. Follow the same process. If B is the midpoint of QR, C is the midpoint of RS, D is the midpoint of PS, you should get these four coordinates for your midpoints. Okay, now that you have that with these 4 points, try and prove these 4 points form a parallelogram. Okay, so you can check your slope calculations there. So I found the slopes of AB and CD to both be negative 5 over 8. So those two sides are parallel to each other, those two opposite sides. And the slopes of BC and AD are both 5 over 4. So those two sides are parallel to each other. So we've shown that opposite sides of this quadrilateral ABCD are parallel to each other. So we have a parallelogram. This is actually one of these theories that's true for any quadrilateral. If you connect all the mid-segments, you will get a parallelogram every single time, which is kind of neat. But now you've proved it using slopes, and that's it. So that's it, that's all. There's a couple other proofs to try in your homework here, and good luck, and let me know if you have any questions.